In this video, we're just going to look at the steps for applying a new technique called the node voltage method. Often I'll just abbreviate this as NVM. And so the reason we want to look at node voltage method is that sometimes our previous methods aren't always going to work, and this method is going to give us a more algorithmic approach. So in this video, again, we're just going to look at these steps for applying the node voltage method, and then in several of the following videos, we're going to work through some examples. So we can see on the slide here, the first step is to identify all of the essential nodes, and recall that an essential node is a node where we have 3 or more elements coming together. The second step is we are going to choose one of the essential nodes to be the reference node and label it as such. There's really not a wrong choice for the reference node, but we'll talk about some reasons why we might choose one node over others as we work through some of the examples later on. So step 3, after we've assigned a reference node, we now assign our node voltages to all of the essential nodes that are not the reference node. And each of those node voltages is going to be negative at the reference node, or in other words, it's going to be referenced to the reference node. Step 4 is we are going to then apply KCL at each of those essential nodes that's not the reference node, and we're going to use Ohm's law and KVL to get those currents in terms of the node voltages. So what we're going to be left with then is a set of equations that only have the node voltages. And as we see in step 5, what we're going to end up with is n sub e minus 1, where as we see up in step 1, n sub e was the number of essential nodes. So for example, if we had a circuit with 3 essential nodes, we would end up with 3 minus 1 or 2 equations, and we are going to solve those simultaneous equations for our node voltages. Now, step 6, sometimes we will need, sometimes we won't, depending on what a problem is asking. But in step 6, we're then going to use those node voltages, and we can find any other parameter of interest in the circuit, whether it be a voltage, a current, or a power.